Welcome. While people are getting situated, I'm just going to go ahead and introduce myself really quickly, because I think, in fact, probably most of you don't know me, despite the fact that I've done several NDCs, but it's been many, seems like many years. The last NDC I did was in Porto, except that it wasn't in Porto because that was the year that, everybody got sick, and so I sat in a little room in my house and talked to people who were also sitting in a little room in their house, and it was a very disappointing experience. Great conference, but not what you want out of a conference. So I'm really happy to be here and to actually see you in person. It's great to be back. So thanks for coming out. My name is Thomson. I'm a product manager at a company called StackLock. We work on software supply chain security, especially around generative AI. I'm not here to talk to you about that today. I'm here to talk to you about version control. I've been working on version control for the last quarter century of my life, which is why I'm now a product manager in something completely different, because spending too much time with Git can kind of warp your mind a little bit. But my hope is that that we can work on that a little bit together, because it is a thing that we all use together. I'm still active in version control. It's something that I do. Personally, I work on a project called libgit2. It's a tool that lets you manipulate Git repositories from a library. So if you're writing C, if you're writing C#, if you're writing Node, and you want to talk to a Git repository, you can use libgit2, and I hope that you do, and I would love to hear about it and the problems that you have, the things that you're doing with it if you do. But most of us actually interact with Git on the command line, and that is sort of fun sometimes. I find Git a little bit challenging to use on a day-to-day basis. Maybe you do too. Maybe that's why you're here. So my goal out of this session is to help you use Git a little bit better, fundamentally to make it a little bit more fun, a little bit more easy, and a little bit more productive. This is the obligatory audience participation part. Sorry, this is the only part. Raise your hand if you think Git is easy to use. Holy cow. Okay, there are a few hands. Thank you. Thank you. I actually don't. I don't agree with you. I don't think it's easy to use. I think it's a little bit complicated. Raise your hand if you think Git is fun to use. Do you find joy? Does it spark joy in your life? Not a single hand up. Wow. I have this hypothesis that all products are sort of caricatures of their creators. And I don't think that Git is easy or fun to use, but it is very powerful and it is very flexible. And I think that jokes aside, I do actually think that that's what Linus Torvalds intended for Git. In one of the early posts that he made, and this was many years ago when Git was a lot fewer commands, he mentioned that it was not really an SCM, but you could build one on top of it. And I think that we can, and I think that it's a little bit up to us. Because Git is incredibly flexible, it is not very opinionated. And so we get into these occasions where we're trying to do something with Git and we don't really know how. And that's sometimes because there's 8 ways to do something, right? What does the checkout command do? Well, it switches branches, or it creates branches, or it actually checks out an older file from a different commit, or it restores the changes that you've made or undoes the change. It does 8 completely different things. And so you've got to know all these things. And so my goal here today is to give you some new tips, some new tricks, some ideas for how to use Git a little bit more powerfully. And my goal, my sort of fundamental goal, is that everybody here learns something new today about the Git version control system, which I think is important because all of us use it on a daily basis. And I will put my money where my mouth is. If you don't learn something new today, one thing, if you don't come out of this session learning one thing at all, I will buy you a pint. Now, I've sort of stacked the deck in my own favor because I'm throwing in some tools, perhaps those even that I wrote that you've probably never used. But if you have, I will buy you a pint, and I will be happy to do so. So the first thing that I think everybody should know, whether you want to do it or not, whether you think that this is right for you, whether you think that this is worth your time, I think that everybody should understand a little bit more about how to customize the user experience of Git. Because out of the box, I think it's a little clunky sometimes. And in fact, it's differently clunky if you're a Linux user or a Mac user or a Windows user. Git for Windows comes with very different defaults than what you see on Mac. And so my suggestion is that you perhaps throw off the shackles of the defaults and go and customize your own experience. Optional, but I think that it's very powerful. I think that it's especially powerful when you start changing the Git configuration a little bit. If you've never changed your Git config, there are two ways to do it. You can either run the command git config -- global, and then you give it the key, which is always within a section. There are no keys that aren't in sections. Some are in multiple sections. It's a little complicated. Don't worry about that part. And then you give it a value. You always want to edit your global Git config when you're making customizations, because that, when it says global, what that really means is for your user. So not, by default, if you omit the -- global flag, it'll edit the Git config in your current repository. So you want to be able to make configuration changes, stick for your user for all of the repositories that you clone, and so you use git config -- global. You can also edit the .git config file in your home directory, and I forget exactly where that is on Windows, so it might be easier to use the command, but fundamentally, this is how you change your git config. And I think that one of the biggest values, one of the most important things that I find when I'm changing my Git configuration is adding aliases. So aliases are a built-in part of the Git command line, and they let you take a short command that doesn't exist within Git and give it to a longer command. In other words, you can say things like, alias, you could potentially say alias C for clone, and then you could run git C instead of git clone. I don't think that that's particularly useful, but hey, maybe you do. I can imagine a world where, if it's hard to type, if you want to save keystrokes, and that's actually valuable to you, it's not as valuable to me, but git C might be a great alias. But what it does let you do is stop having to remember some of the arcane flags that you have to use, and really save keystrokes that way. Because I think a lot of the Git commands are not helpful, or as helpful as they could be, until you start adding flags on top. Let me show you a couple examples. So, is this big enough? Can you read that in the back? Okay, great. Yell, I can make it louder. One of the things, I think the most common command that I run in Git is log. I want to understand what has been happening in my repository. You run git log to do that. That's what shows your history. However, I don't actually like this format. This isn't how I think about history. I ran git log and I see 4 commits, the 4 most recent commits, and I got to scroll down and scroll down and scroll down, and it's not very information dense. So I don't like that. So the command, the git command that I run more than anything is git lol. Now, I've set up an alias for git lol, which is log 1 line, and that is much more information dense. This gives me all the information that 25, 30, however many lines that is, that's showing me each commit 1 per line. Now, I don't get the entire commit history, but sometimes that's okay. I get a snapshot of what I'm looking at, and I can go dig deeper into any individual commit that I want to see if I want that complete history, and then even see the files that are in there. That's one. The second sort of most popular command that I use is called git graph. Now, if you run git graph, it will do nothing. It will tell you that it's not found. I've set up an alias for git log one line dash dash graph. And now I can actually see how things have changed over time. Let me zoom in a little bit for you. So over here on the left, you can see the actual graph, how things have changed. You can see that there was a little pull request here that came in. It had a handful of individual commits. It got merged right here. And that's the sort of thing that straight up git log or even my nice git lol alias won't show you. So by adding dash dash graph, I can do that. And so what does that actually look like? I can edit my git config, and we'll just leave this open because I've got a handful. It's these 3 lines right here. So I've got an alias section. LOL is graph dash dash one, log dash dash one line dash dash decorate. Graph is log dash dash one line dash dash graph dash dash decorate. So I mention that because as I go through, there we go. As I'm talking about other git commands, I'm gonna mention other flags that you can use, other configuration settings that you can use. And so I think it's important to know how, if you want to opt into these things, you edit your config and how you set up aliases. The other thing that I always do when I pave a new machine is I change the colors. If we take another look at this, at git log, it's not the worst thing in the world, but it is I don't know, I just don't like the yellow. That's not great. And I don't like the green. Actually, I just don't like it. So I mentioned that I've been writing version control software for a really long time. I've actually been in the industry for an even longer time, and I grew up not with, I don't know, fancy VS Code. I didn't even grow up with Visual Studio. My first editor was QuickBasic. And it's sort of baked into my head. This color scheme, to me, is sort of nostalgia. And actually, I don't even really like this very much. I think Microsoft didn't quite have it. They didn't quite have the taste here. That red on blue is really hard to read. Maybe it was easier on a CRT, I don't remember, but it's tough right now, isn't it? I think Borland really had it. This is, in my head, what developer tools should look like. Dark blue, lighter blue, some pinks. I don't know. I find that really, really enjoyable. And so what can we do with Git? Well, there is this notion of the ability to change your colors in Git. So we can get rid of that yellow. We can get rid of that green. And the way you do that is by specifying the colors that you want. Let's take a look. So I'm going to pop over. I'm going to open up my Git config. I think it's still open. There it is. I'm going to come down here, this section, color.decorate. OK, so we can change the branch color. We can change the head color. We could actually, head is the color of the word head that indicates the branch that you're on. Save that. And if I run git log, oh my God, that's really hard to read, isn't it? What's happened here, and again, if you're old enough to remember QuickBasic, if you're old enough to remember Borland, Turbo C, you are probably old enough to remember the CGA color palette. You got a whopping 16 colors. All that you could possibly ask for. All 16 were available as a foreground color, and only the top 7 were available as background colors. And then, they had sort of funny names, like brown was sometimes just called yellow, and yellow is sometimes called bright yellow. It really made no sense. But that's what Git offers you. If you actually look at the Git man page, it will tell you that you have your choice of any color you want as long as it's one of these 16. And it actually sort of remembers that nonsense. Brown is in fact yellow. Yellow is bold yellow. It really doesn't make any sense. However, undocumented feature, this isn't actually in the Git docs, if you have a more modern terminal, so you're not using CGA, maybe you have a Mac or a Windows machine that's been built in the last decade or so, you can actually use 256 colors. if you look in the source code, not in the documentation, in the source code, it'll tell you to use one of these numbers. So you have to figure out what these numbers are and map it to your Git config. Exceedingly painful. An even less documented feature is you can actually use hex color codes, and I'm pretty sure, not positive, because I only went so far down this rabbit hole reading the Git source code, that you actually have to use the identical hex number. So like, you can't say, oh, I found this color in color picker and here's its hex code. If you get it wrong, you get gray. You've really got to nail it perfectly. So you can use the colors, you can not. But once you do, you can get something more like what you want. So color number 41. Oh, sorry. Let's get out of there. There we go. Okay, so color number 41 looks like what I want. I don't actually remember, I'm just picking that at random. Yeah, that looks pretty good. And then I think you can actually, you gotta quote it, special Git tip, gotta quote things with that start with the number sign, the hash mark. Let's do that color. If you know your RGBs, you'll know that that's a sort of ugly magenta, but it's something. And of course, you can iterate on this to your heart's content. You know, if you're the sort of person that likes tinkering with their VS Code themes, you might enjoy tinkering with your Git colors as well. I certainly do, at least to get, I don't know, something a little less. I don't know. I just find that yellow jarring. If you do too, it's a great thing to fix. Okay. So, there we go. So you can actually read the Git man page, the Git config man page. So you can either run git help config to do that, or you can run man git config if you're on a Unix machine, or you can just put it into Google and get the man page that way. It's probably the easiest way. So when you do that, just remember that you do actually have a full set of 256 colors. I think if you're using one of the even really more modern terminals, like Ghost TTY, you can actually get millions of colors. I have no idea, I couldn't make that work either. And allegedly you can do that on Windows, but that worked even less. I played around with Git for Windows to see how that worked, and I got all 16 colors, like it was 1985 all over again. So a tip, if you're a Windows user, when you installed Git for Windows, it probably gave you this installer screen that asked you like a dozen questions, and most of them make no sense. It asks you things like, how do you want to handle your line endings, as if there's a comprehensible answer to that. We can talk more about that later. As you're going through, if you do a reinstall, you can say, I want to use min-tty. And it doesn't tell you why you would actually want to use min-tty. The best answer I can come up with is because you get more than 16 colors. I actually find that compelling. I find the Windows terminal color is especially hard to read by default. So if you choose min-tty when you do the install, you can have more colors. So that I hope makes Git a little bit more pleasant to use, but there's actually a lot of things that we can do to make Git more useful for us. The thing that I do most, right? Like I said that git log was my most, or variations thereof, is like the most common thing that I do. Fundamentally, like the way that I work with Git, you know, I commit sometimes, I merge sometimes, but most of the things that I do are like finding things. Where is my code? How has it changed? That's what I use Git to understand. And so I think that that's important because all of my stuff is in a Git repository. I mean, I check in my documentation into a Git repository. I check in notes, like when I talk to a customer, I put it in Markdown and check it into a Git repository. So I think that it's very useful to use Git to help us find things, find those notes, find how the code has changed over time. Whatever your job function is at that day, how can Git help us? Well, the first tool that probably the second most thing that I run in Git. The first thing is log, the second thing is Git grep. If you're a Unix user, you certainly know what grep is. I forget exactly what it stands for. It's one of those silly Unix command names. like abbreviations like global regex, or there's a P. I don't know where the P comes from. Doesn't matter. grep, if you're not familiar with it, looks through files given a pattern. And so you can say, like, I don't know, let's say you want to find all the copyrights. You know, it's January. If you're the sort of person that puts a year on a copyright, which, you know, maybe every year you should rethink that decision. But if you're the sort of person that puts a year on a copyright, you need to find them all. And so you would run a grep. You can grep copyright within your path, and it'll show you these things. But there's also git grep, which will grep through your git head, your git commits for the same thing. I'm actually a convert on git grep. I didn't use it until really, really recently. I would either run grep. If I had rgrep, I would use that. You know, if on an older machine, you could use find. If you've ever used find and grep together, it's exceedingly painful. If you're on Windows, I don't even know how that works. But I'm a recent convert on git grep. The reasons that git grep, I think, is better than regular grep is it avoids build artifacts. If you're writing in C or anything that gets compiled to a binary or to object code as intermediates, you don't want to grep through your binaries. You don't want to grep through those object files. A, it's slow. B, it'll give you false positives. Like, right, if you're putting copyrights in, you want to find the source of the copyrights, not where copyright exists in the binary. That'll get compiled out. The other thing that it's useful for, though, is like if you're just grepping through your work tree, you can only find the stuff that's in your work tree. Seems sensible. Git grep will let you search other commits, other branches, other places. But the other thing that's really useful about git grep is that it's much faster. Git grep actually runs multi-threaded by default, so if you've got a multi-core machine, which I hope you do in 2025, if not, you really ought to be hitting the job market while you're at NDC. But if you have a multi-core machine, it will parallelize the grep across multi-cores, so much, much faster by default. So let's, nope. Come on now. There we go. So if again, we can git grep for the copyright, which is pretty useful. But I think the more useful thing about git grep is that you can change its mode. By default, it lets you put regular expressions in. And yes, I understand regular expressions are not that great, but they are useful and they are powerful, and they do come in handy sometimes. And so you can change your git config and turn on Perl mode. Let's take a look at that on the slide, sorry. But I can git grep. If by default, I want to look for copyright. So let's say copyright, maybe it starts with C, a capital C, maybe it doesn't. I want some white space after that, and then I want a number. Ooh, nothing happened. So I can use various modes to git grep. And again, these are the sort of things that you've got to remember. -P will enable Perl-compatible regular expressions instead of standard regular expressions. Like, I actually don't know what a standard regular expression is anymore because I don't know why that wouldn't work. But you can use git grep -P, and now all of a sudden we see all of the lines and all of the files in my source tree that say copyright and then a number. I could even make it, you know, 4-digit number to really be a year. This is probably enough. But I think that's a really useful little change that we can make. And so that's one of the things that goes into my git config every time is pattern type equals Perl. So you can add that to your git config, and now you don't have to remember that it's -P. The other thing you can do is add line number. So grep.line number is the configuration option. And instead of just having a list of files, so if I edit my config, grep line number equals true, Now when I run that, instead of just having the file name, that's the default grep output, I get the file name and the line number that it's on. That's especially useful for scripting if I want to write, if it's January and I want to be a little less lazy, I could write a script that could go and change all my files copyrights for me. The way I would do that is by knowing the file name and the line number. Super helpful for scripting, helpful even if you're not. So these are the things that I have in my Git config. There's more that you want to find in your Git history. In particular, one of the things that I want to understand is how my repository has changed over time, and really how my view of the repository has changed over time, right? Like git log shows you everything that's gone into a branch, everything that's gone into the main branch. The thing that I really want to do is look at how what I've been working on has changed over time, because it's often that I'll like start working on a thing, I'll get interrupted, I'll switch branches, and then I'll want to go back to it, but I'll kind of forget the context. It's easy to lose context as humans. There's a thing called reflog that can really help here. So first, let me just show you what reflog looks like. If you're not familiar with it, what does reflog look like if you just run it? Well, this is really dense. It sort of looks like log, like the shortened log that we were looking at, except that it's got a little bit more information if you're looking at it. You'll see that what happens is it's got a bunch of different branch names. Why does it have different branch names in here? Well, this shows me how I'm moving back and forth between branches. I switched up here, a couple lines down, I switched over to the change_version branch, then I went back to main, and in here, there's some other weird stuff. What's happening here is that I was doing a rebase, and you can sort of see that. It says it right here, rebase start, and then these are the actual rebase operations. Super dense. And not actually particularly helpful, because I want to answer questions like, what was I working on yesterday, or what was I working on earlier today before I switched contexts and worked on something different? And you'll notice that there's no dates anywhere here. So I can't answer the question, what was I working on? I might have switched branches earlier today. I might have switched branches a week ago. I have no idea based on looking at this. So one thing that I can do, though, is git reflog --date equals ISO. Date equals ISO. Sort of weird. The date format for ISO means the date that I changed the reflog, not the date that I did the commit. Any other date format will show. This is one of those like maddening things about Git that just sort of doesn't make any sense. This is why you use Git aliases, so you don't have to remember this. You can get this out of your head unless you work on a Git library like I do, in which case it's just taking up space that could be used for other things. You don't have to put an alias here. But what it does show you now is head at 2025-01-30. So this is right before this talk. So this was what I was doing right before this talk, was doing this rebase. If I scroll down, I can go through history and see how what I've been working on in this particular repository, in this particular directory, has changed over time. I think that is particularly useful. The other thing, though, is just like log by default shows you a ton of output, and you can do log --1 line to show you a little less output. Reflog by default shows you, well, the defaults are backwards. Reflog shows you a terse view, but you can get that more informative, deeper information by running git reflog --pretty. Why pretty? I don't know. This output doesn't look pretty to me. It does look detailed. Maybe they could have used it better. Descriptor, they didn't. You're going to have to create an alias so that you can remember what it should be. But this will give you more context about the commits that were happening during that time. So again, git reflog --date equals ISO. Helpful, shows you how things have changed. --pretty tells you tells you more information about the changes. Here's a fun one. This is my like get out of jail free card to avoid buying the entire room a pint after the talk. Git recover. Git recover will look at your repository, and it's kind of like the old undelete command in DOS. Again, I know I keep talking about the ye olde times. If you lose some changes in your working directory, but at one point Git knew about them because you ran git add or something along those lines, you can recover this data for a little while. Let's call it 2 weeks. That's a pretty good default. So let's just do that. Let's make some changes and then lose them. Let's open up my README. Let's make a great change that we don't want to lose. And then let's run git add, git status. OK, so this is a change to be committed, but we haven't actually committed it. And then I'm going to run git reset -- hard, obliterate my changes. I haven't checked it in. That file is all gone. OK, now, can I get it back? The answer is yes, you can run git recover. And git recover will tell you about quote unquote orphaned blobs. So what happened is, when we ran git add, it didn't commit the changes or anything, but what it does do is it puts that change, the new contents, into the object database. And then when we ran git reset, we obliterated any pointer to that thing in the object database, so it became garbage, and eventually Git will garbage collect it, but it hasn't yet. I can say git recover. I could look at these files before I make any changes. If I can run git cat file, blob, and then give it that ID. And if I scroll up, I can see that this is in fact my README, and it does in fact have my really great change. And then I can actually restore it. Whoops. We can look at what the commit is. We'll copy that commit hash, or that blob hash rather, that object ID, and recover it, and it puts it on disk. One thing it doesn't do is remember the file name that it had, and that's fine, but I do actually get the contents back, and so that I can put them back into place. That was readme.md, and now if I run git status, I've got that diff again, right? So that change came back. So even though I'm able to make changes with Git, even when I don't commit them, they do actually go somewhere in Git for at least a little while. The interesting thing here is a sort of syntactical thing that you may have heard about when it comes to the index or the staging area, or the cache. That same concept has 3 different names in Git. But the important thing about it is sometimes you'll hear, well, that's the changes, and Git even calls it that. These are the changes to be committed, right? Up here, when you run git status, it says, there are no changes staged for commit. If I run git add, and then run git status again, these are changes to be committed. And so there's sort of an interesting linguistic thing here that's going on. These changes to be committed are in the index. So it's added them to the object database, it's added them to the index, and what a commit does in Git is it takes the index and converts it to a commit. And so anything that is or has been in the index is in the object database, at least, again, for a couple weeks, and you can get it back. So if you ever make a change and lose that change, you can get it back with git recover. Now, again, I actually happened to write this tool because I needed it. You can go grab it from GitHub. It's not part of Git. And so, you can grab it. Just Google git recover, and it will take you to the right place. You can download it. You can install it. Once you install it, there's a fun thing about Git. If you install a tool called git-recover in your path, you can run git space recover, and it'll work. It's kind of like aliases maybe on acid, really, that you can just sort of litter your file system in your path with these changes, and they will just start working. So I hope you find it useful. If you are in fact using it, I'll buy you a pint. Give it a look if you are the sort of person who wildly experiments in Git repositories, like I am, and then says, oops, where'd that change go? The other thing about finding changes, finding things in your Git repository, is understanding how your code has changed, not just where it is. I think that the sort of gold standard for how has my code changed is git diff, and there's a particular option to git diff that you may not have seen, may not have used, called word diff. I think git word diff is incredibly useful and powerful. So if I just want to understand how this source tree has changed, I'm in the tip of the main branch. The last release of libgit2 we did was version 1.9.0. If I want to understand what has changed in the main branch since we released Git version 1.9.0, I'm going to run git diff v 1.9.0, and it's going to tell me a lot. And things get really dense, especially multi-line stuff. Like, what on earth is going on in here? It's a GitHub Actions workflow, which is already bad. It's using CMake, which is already worse. And like, it's 3 lines of text, and I sort of don't understand what's changed. I think I see a change, but I'm not sure that that's the only one. I don't know. It's hard for me to parse, and I want something simpler. So I can run git diff -word -diff, and again, if you struggle to remember that like I do, you can create an alias for it. Oops. In fact, see, I got it wrong. Let's go back. Oh, right. It is git diff -word diff. I need the v 1.9.0. So how has my main branch changed against v 1.9.0? Well, those first 3 lines are basically the same, except that now they've got a little more markup. There's a brace and a plus around it. That indicates that the whole line has changed. In fact, the whole line's been added. But down here, I can actually see a lot more easily. It filters out the noise. Instead of just showing it as one whole line that has changed, you know, a red line and then a green line, it shows me the context of that line in white. And then it only shows me the actual changes in red and green. So it's much, much easier to figure out what's changed just on a line-by-line basis. And I can scroll through and see, you know, a lot more, I don't know, simplistic output. A lot easier for me to parse. This is sort of my go-to is word diff, and again, yes, I do have an alias for it. The other tool that I use a lot is git blame. Git blame shows you, it's kind of a terrible name. Back in the old days in Subversion, and I think CVS as well, it was called annotated history, so you could run, yes, you could run blame, but you could also just call it CVS annotate, and I thought that was a much more, you know, maybe a little bit less aggressive. I don't like the, you know, tech bro aggro culture. I don't want to be blaming my coworkers because they're going to come back, and if for no other reason, they're going to come back, excuse me, and blame me when I put a bug in. So, you know, maybe let's not. The interesting thing about git blame is that there are options that you may not actually know about, and this is my favorite. -C. You need 3 C's. Forget what each one does. But basically, each one sort of increases the depth that blame will dig as it's looking for understanding the authorship of a line. So if you just run git blame, it will tell you literally where that line, here, let's take a look. If you run just like git blame on readme, it's a little noisy. Let's scroll down to something that's got a, you know, maybe a little smaller. So, you know, the first thing it shows you is the commit. Second thing it shows you is the file name that existed during that commit, who did the commit, when did it happen, and then the actual line itself. This is git blame output. As you start adding -C's, it will look more deeply, right? Like, so this line was changed in commit 8F96C, blah, blah, blah. But as you add a -C, it will say, oh, well, maybe that line was actually copied from somewhere else. And so it will look to see where the original change came in. Another C, well, maybe it came from a different file. Another C, well, maybe it came from a different commit altogether and was copied in or moved in. So you can add git blame, ccc, readme.md, and it admittedly does take a little bit longer, but the results are actually a bit impressive. So if I look at the original git blame, let's look for this section down here. Using CMake. Okay, my buddy Vicent added this in 2011. It's been around forever. Where could it have possibly come from except, from Vicent who added it, except that he didn't. He did a little bit of refactoring. And so if I actually add the -c rather, and I give it a second, and I search down and look for the using CMake section, well actually Peter Drahosh added this change in December of 2010 as part of the line below it even. And so it actually makes a lot of sense. Vicent just came in and did some cleanups, did some reorganization. He is not in fact to blame for adding the using CMake instructions. That's Peter, or in this case, to thank. Right? You can use blame to give gratitude to your coworkers, and I encourage you to do so. So I would, instead of going to Vicent and saying, hey, thanks for adding those great documentations, he's going to stare at me, especially since it's, 15 years later. Instead, I can go to Peter, who will, again, stare at me since it's been 15 years since he made this change. But at least I can get the sideways stare, not knowing what on earth they're talking about from the right person. Where has my cursor gone? There it is. So blame, super useful, but I find -c, and yes, I have an alias for this, to be the most useful sort of addition to blame. So beyond finding things, the thing that I do with Git most often is fixing things. In particular, merging things. As an open source maintainer, I spend a lot of time taking people's patches, taking people's branches, and integrating them with the rest of the code base. And when somebody, makes a change in my open source project, I have no earthly idea what version it is that they've decided to make their change to. Sometimes they'll clone the repository, check main out, make their changes, and send a pull request based on that. Sometimes, and in fact, maybe even more often, they'll pick the version of the software that they're using because they need to be able to patch production. They want to build a change that they can actually use. And so they'll check out like some older version, make some commits, and send those as a pull request. And when that happens, you almost always have a merge conflict. If you're not familiar with the way the merge algorithm, this is a standard three-way merge algorithm. It's the same that, Git does it exactly the same way that Subversion did it, with a few minor details, exactly the same way that CVS did it. The idea is that you have a common ancestor. You know what that common ancestor is. The difference in Git is that it's really obvious what the common ancestor is because it's all built on a DAG, whereas Subversion had to remember a lot of metadata. Don't have to worry about that. The fundamentals are the same in that you have a common ancestor. And that's the point at which the two branches diverge. In one branch, whether that's the main branch or whatnot, Git calls it the hours branch, you make some changes. So here we change line 2 and 3 in one branch, and in the theirs branch, in the other branch, you make some changes. Here it's lines 7 and 8. The way Git merge works is it just goes line by line. I'm simplifying a little bit here, but not very much. It goes line by line, looking to see what's different in each branch from the common ancestor. Neither branch changed the first line, so the post image, the merge result, line 1 will be the same. It's the same in all three, it's just the same, very easy. In lines 2 and 3, our branch changed it, but their branch didn't. So we'll take the version from our branch. 4, 5, and 6, no change, they're all the same. Lines 7 and 8 were changed in their branch, but not in our branch, so we take the changes. And so that's the way three-way merge works. It's actually very simple and straightforward, and so you get the blended merge output. Now, there's no guarantee that this actually works, right? Like the two changes could conflict with each other semantically. Git doesn't really know what your code does or looks like. All Git knows is that you didn't change the same lines, and so there's not a conflict. Great, but sometimes you do change the same lines, and that's when you do get a conflict. In this case, our branch changes lines 4, 5, and 6. Their branch changes 5, 6, and 7. Which line 5 do you want? Which line 6 do you want? Have no idea. Git certainly has no idea. So what it does is it gives you a conflict. It puts these angry arrows in your file, and you've got to figure it out. That part is fair enough, right? Like, there are syntactically aware semantic merge engines that may be able to help here, but honestly, maybe not. Like this particular example, there's just nothing to do. There's nothing to figure out. And so you do, as an operator, as the person doing the merge, you have to figure out how to do that merge. I think that this is a particularly annoying issue in Git. So I've got a branch here. Oh, sorry, I have some stray changes still in my README. Great. So now, if I run git merge of a different commit, these are the output messages. It yells at me about a conflict. If I go and look at one of these files that is in conflict, right, I get the angry arrows that I mentioned. There's a way to get more context out of this, which I think is incredibly helpful, right? Because right now I'm just looking at, this is what's on my side, the head side. This is what's on the other side. Obviously, the other side added a bunch of code, but I don't really understand what was there before. So in your Git config, you can turn on conflict style equals diff3. Diff3 means that when it shows a conflict, when it puts a conflict in the file, instead of just dumping out the state, it will actually add more context, in particular the context about the common ancestor. And so if I abort that merge and then do it again, git merge origin e Thomson keep alive. This is a real branch that has been languishing and does in fact need to be updated with its merge conflicts. Now if I go look at this file, I've still got the angry arrows, but now I've got this section surrounded by pipes. Not the most elegant solution, but this now is the common ancestor. And so I can see how I've made the change. I've gotten rid of this particular call, this particular second argument to the function. And the other side has added all of this sort of interesting complexity. So I probably, the resolution is actually pretty straightforward. I want to keep this from the other branch and just get rid of that call. And so I can actually resolve the conflict really easily like that. Great. That was much easier than me trying to figure out what had changed on the other side. I actually see it a little bit, maybe not as much as you would like, but you get a little bit more context about it. The other thing that you can do is you can set up a merge tool. So you don't have to have the angry conflict markers. I actually find those really difficult to deal with. And it was a surprise to me coming to Git from working in other version control systems and working on other version control systems. Team Foundation version control, for all of the terrible things you can say about it, doesn't give you that nonsense when you have a merge conflict. It opens a nice three-way merge editor. And so you can turn that on. In fact, you can turn on the one from Team Foundation version control. If you're a Visual Studio user, it comes and ships, and I actually think it's a pretty good tool. If you're not a Windows user, if you don't have Visual Studio, you can download a handful of other options. There are many free options. The one that I like is called SourceGear Diff Merge. There's a reason for that. I actually used to work at SourceGear on version control tools there, so I still have a fondness in my heart for it, although when you open it, you'll see it does look positively ancient. And you can invoke that by setting it up in your Git config. Let's take a look at that. I have set up merge tool, SGDM, which is source gear diff merge, and then some configuration. And you can Google all of this and understand how to add the particular merge tool that you like to Git. And then once you've done that, instead of just after you've done the Git merge, right? I'm still doing the merge. I still have conflicts that you can see down here. I can run git merge tool on one of the files. And when I do that, it will open up source gear diff merge. Font's a little small. It's a little bit hard to read. But once I do that, I can pop down and I can actually look at the conflict with a lot of extra context, right? So right here is one side, this is the common ancestor, this is the other side, and I can just drag hunks of code in back and forth. VS Code can do this, Vim can do this if you're that sort of a person. I'm sure Emacs can do that if you're that sort of a person, and I'm sure you'll also tell me afterwards if you are. It's kind of like being a vegan, no shade, I love it all. Please tell me how your Emacs setup works. I'm excited to hear about it. That's not sarcasm. But you can use any of these sorts of tools that you want to get you out of that angry arrow conflict experience. Like, conflicts are bad enough. It is painful enough to resolve these conflicts, even with good tools. So you shouldn't be shackled to bad tools. You should use exactly the tool that you want. So, skipping through. Right, so again, that configuration option is merge.conflict style equals diff3. I'll put all these slides online, and so you don't have to like scribble these notes down. You can find them on my GitHub. I'll have a link afterwards, and then I'll upload them later today. Again, merge tools. You don't have to remember this either, even less so. Any merge tool in 2025 will tell you how to configure it with Git, and probably other version control systems too, as if any of those are actually used. But, you never know. Speaking of conflicts, the other powerful Git utility that I use around conflicts is called Rerere. This echoes back to the -C and design decisions around Git, and boy, if only they had a product designer. But they don't, and so we're stuck with commands like Rerere, which stands for remember recorded resolution, I think. If you do a lot of merging, and especially if you do a lot of rebasing, you will get a lot of conflicts. Rebasing in particular, because you're cherry picking commits over and over and over again. And so you can often end up in this like sort of situation where you see the same conflicts over and over again. And wouldn't it be nice if Git just remembered how those conflicts were resolved? Well, it can, and that's called Rerere. You can turn it on with a Git config option called rerere.enabled equals true. And when you do that, I think I've got it off. OK, so when I turn that back on, now if I git rebase my changes on my main branch, I'm going to hit a conflict. Actually, sorry. Let me go back to reflog. I think I actually wanted to be right. There we go. That's where I wanted to be. OK, so now if I do a rebase, if I rebase on main, I have a conflict. It's in this file right here. If I open up this file, this is a straightforward conflict. I don't have to think too much about it. One side added one include, the other side added the other include. Shouldn't be any problems. OK, I'll just resolve that, add it, which marks it as resolved, and then rebase -- continue. And when I do, I've got more conflicts, right? The way, again, rebase works is it figures out where you're at versus where you want to be and applies, it basically cherry picks all the other commits on top of you, or cherry picks your commits on top of the target, rather. And so you can get into this place where you just endless cycles of git commits and sometimes git conflicts, and sometimes you just need to get something done. So maybe you need to, again, switch contexts, fix a different bug, that sort of thing. And if you end up aborting your rebase, by default, what happens if you want to go do that rebase again? Well, you've got those conflicts again. With Rerere, if I go and rebase origin main, you'll note here, it still tells me that there's a conflict. But it says, well, I actually know how you resolved that last time, because you made the change, you ran git add, and if I open the file, it's there. It's already, Git has fixed it for me. It's taken that previous resolution. So all I need to do is check that out, make sure that it's what I want, and then I can git rebase dash dash, git add the file again, and then git rebase dash dash continue, but I don't have to deal with the conflicts. And then I can just keep going and dealing with all the other future conflicts. So it doesn't actually solve you from resolving conflicts more than once, but it does keep you from having to resolve it more than once, which is indeed very helpful sometimes. Couple of final things that I would encourage you to do. You can set up a global Gitignore file. So to your configuration, you can add this option called core.excludes file and give it a file path. Why would you do that? Well, and in fact, in open source projects, you'll see this a lot where people are arguing about what should be in the git include. And people will try to put in their editor lock files, swap files, and sort of temporary files, and maintainers will say, please don't make a mess of this. Why are you doing this? The way that you should get rid of swap files is by adding it to your Gitignore. So my Gitignore, my core.excludes file rather, in my home directory looks like this. I'm a Vim user, so I've got .swp. Now these won't land accidentally in version control. I've got .swo, which is the next level of Vim swap files. If I'm on a Mac, I might want to exclude .dsstore. And that will just make sure that I don't accidentally add these files. It'll just Gitignore them. Very sort of useful thing, especially if you move from repository to repository. You don't have to think about setting up a Gitignore in all of those places. Another feature that I really like out in the Git config is what's called conditional includes. I work on open source projects. I work on projects at my company. And one of the things that I don't want is one thing that I do want is to make sure that I can separate the Git config that I use for my company projects from my personal projects. And so my home directory sort of looks like this. I've got this directory called personal. It's got my personal projects in it. I've got a directory called stacklock. That's where the Minder open source project lives. It's my day job. Minder rules and profiles, another repository we have. And I can actually shard between some settings by using conditional includes. It's called include if, and then you give it a path. So any repository that's in users Thomson libgit2, my git config will include this file, config.libgit2. In this path, it'll include gitconfig.stacklock. And what I use that for is to change my email address so that when I'm looking at stacklock projects, it doesn't look like my personal account. And on libgit2, it doesn't look like my stacklock email address. So you can arbitrate those sorts of changes through this sort of a setup. It's relatively simplistic. I find it useful because it always pains me when I accidentally get that wrong and I'm looking through, say, libgit2 and I see ethompson@microsoft.com when I haven't worked there in many, many years, and that email address definitely won't work. Or maybe it will, and it's just Elise Thomson. I don't know. So don't bother her with problems with libgit2. Come bother me, and I'll make sure to get that right by using conditional includes. So I do that sort of setup in each particular file. And again, I'll put all these slides online afterwards. One last quick thing, because we're almost out of time, but line ending filtering. I said the audience participation part was over. I lied to you, I'm sorry. Raise your hand if you're a Windows user. Okay, this is important for you. Windows by default uses /r/n, carriage return line feed. Unix by default uses just new lines. And Git, was built by the guy who built Linux. And he sort of didn't imagine a world where people would be using Git and using Windows-style line feeds. So Git really doesn't work very well with them. And so you'll hear people telling you to use core.autocrlf. You should ignore them. Do not listen to those people. The Git for Windows installer will even tell you that. And ignore that too. What you need to do in your repository is set up a Git attributes file. That's the new version of core.autocrlf. Right here, star text equals auto. That line should exist in every repository that you have. It's a shame that it has to be that way, but it does. And what that means is, please do the line ending translation when it makes sense, and don't do it when it doesn't make sense. Git maybe should have been smart enough to know that in the first place, but it wasn't. If you rely on this setting, this core.autocrlf setting, you rely on everybody in your organization getting it right, because these settings all have to match. So if there's anybody in your organization who doesn't use that, who doesn't check the right box when they install Git for Windows, you will corrupt very silently and very subtly, you will corrupt your Git repository. And it'll do weird things. It won't be like the end of the world bad. But you'll be like, I didn't change this file. Why does it show up in Git status? If you ever find yourself in that sort of a situation, it's probably because your line ending configuration differs subtly from your coworkers, and the way you can resolve that is by having a Git attributes file with star text equals auto. So please, please, if you do nothing else, if you take nothing else from this conversation, please do change your Git attributes. Anyway, I am actually, I think, over time, so I want to thank you all so much for coming out. Again, my name is Edward Thomson. I will put this on my GitHub so that you can dive in. Please feel free to grab me if you have questions, and feel free to argue with me if you have arguments. But reach out. I'm E. Thomson on GitHub as well, and I'll have this up later today. Thanks so much for coming out.